Hello, welcome to the webinar about the Khronos Group GLTF specification. This is a special meeting of the augmented reality community. It's open and public to everyone, and we certainly welcome participation from all those who are interested in reducing barriers to open and interoperable augmented reality. I trust that includes those of you who are on the call today, as well as I know for a fact it includes our speakers and guests. Today we're going to be hearing a presentation prepared and delivered by Neil Trevitt. He's the Khronos Group president and the vice president of mobile content for NVIDIA. We'll also be able to hear some remarks from Marius Preda from the Institut Télécom Sud Paris, and also the chair of the 3D graphics group at MPEG. So Marius will be able to chime in and speak and make comments. Those of you who might have some additional questions or comments can send a chat message using the GoToWebinar chat feature to me, and I will unmute you so that you can speak and be heard properly. So I think that's pretty much what I'd like to say. This webinar will be available afterwards if you want to share it with other people and review anything that we've covered here today. So with that, I think Neil, it's your show. Please begin.
All right, thank you. Yeah, thank you, Christine. Thank you for hosting it. Thank you to the AR community and the area for the opportunity to give everyone here an update on GLTF. And most of all, thank you all for your time attending this morning. But I hope to do this presentation quite quickly in around 25 minutes or so, and then would welcome any questions and feedback. So for those of you who haven't met Khronos before, we are an open standards consortium. We have about 130 members, everyone from Apple, Google, and Microsoft, all the way down through hardware vendors down to small startup companies that are interested to cooperate to create API standards, royalty-free, that can grow the industry. And we tend to focus on APIs that connect at quite a low level, hardware to software. And our standards are used quite widely in the industry. And Khronos membership is open to anyone if you are interested to join in. This is a webinar around augmented reality, and a number of the Khronos standards relate directly to enabling augmented reality. I think augmented reality, for it to be truly open and interoperable, is going to take quite a great constellation of different types of standards, and we're happy that Khronos can contribute some standards that will help AR reach end users. So this slide shows some of the APIs that we're working on. I'm not going to go into too much detail, but we have OpenVX for low power vision acceleration. We have OpenCL for general purpose parallel heterogeneous computation. We're probably best known for our family of 3D APIs, OpenGLES for mobile, OpenGL for 3D on desktop, WebGL for 3D in browsers, and Vulkan, which is the new generation 3D API that's going to be launched before the end of the year. But our focus from this webinar is actually on the 3D file formats that Khronos also creates. Collada for authoring, interchange of 3D assets, but really we're going to be focused in on one standard today. GLTF stands for OpenGL Transmission Format, for transmitting and authoring 3D runtime assets in applications such as augmented reality. So why does augmented reality care about 3D assets? What is a 3D asset anyway? This is a slide from the work at the AR community, now at ISO, defining a mixed and augmented reality reference model. And this is the classic definition of augmented reality. A user on the right is looking at the world, but that view of the world is being augmented by information and models, augmentations that are being generated, stored, and transmitted on some kind of computer network. Now, many types of AR need 3D assets. Not all. Some types of 3D, some types of augmented reality applications perfectly fine with simpler text and 2D augmentations, but quite a few use cases for augmented reality make good use of 3D, and I've included just a few examples here: architecture, medical, and engine maintenance as an example of a guided task using augmented reality. And this is where GLTF is trying to add value to this constellation of standards, trying to help the authoring and storage, transmission, and use in an AR use case of these 3D models and assets. So if you zoom into this reference model a little bit more, we typically have authoring tools that are creating an augmented reality experience, which includes the augmentations, which can be 2D or 3D. That bunch of assets that makes up an AR experience is typically stored on a server, and then when a user uses the AR-based experience, the necessary materials will be delivered across the network to a client, so the right information can reach the right person at the right time. So where does GLTF play in this larger picture? We're trying to firstly ease the authoring of 3D augmentations and assets. It's a surprisingly clunky workflow that most people use right now. We'll explain more detail. The transmission format kind of gives away perhaps the primary goal of GLTF. It's the optimal delivery of 3D assets, which can get pretty large. If you have a complex 3D scene or model, deliver that large model over a network, perhaps with compression and streaming. And also important for interoperable AR is the concept of using a standard format that many different servers, many different services can offer to a client. So a client is not forced to use just one or two proprietary formats, but can begin to bring down data and assets from perhaps many different services and servers, and avoiding siloed content that only has one use and one target application. So, but before we go much deeper, perhaps it's worth just making sure we all kind of agree on what a 3D asset actually is. Many people, before they think about it too much, think of it's just a bunch of polygons, and that's certainly an important part, of course, of any 3D asset. The scene that's made up a bunch of vertices, and typically in a hierarchy. But there's a lot more that makes up a typical scene. There's materials and textures to paint the geometry model, and also animation and skinning, because very often you want your 3D assets to be animated. And for example, now this is actually the assets from the 3D Santa tracker that's launched every year using WebGL. The reindeer here, it runs, and that's a animation that needs to be transmitted along with the geometry. So if you want to create such a scene or model, how is it typically done today? As I say, it's a pretty typically painful process. Someone who's creating 3D augmentations would use the tools of their choice, Blender, Lithology, Maya, just 3 examples. There are many 3D tools out there, and they all use their own file formats. And in fact, if you do even just a short search in the industry, you can easily find over 30 different 3D file formats that are in use. And many of them, and including the most popular ones like OBJ files, for example, only contain the geometry. They don't contain the rest of the scene data. They don't have lights, cameras, animations, scene hierarchy. It's just a bucket of polygons, which limits their use. Typically, when people are authoring a AR or 3D experience today, they will have a custom content pipeline, which will depend on the tools they're using, will be kind of munging and processing the various formats that the tools are using. Typically, this pipeline is proprietary. Very often, it will be created on a per project basis. And then often, the authoring format that wins through that pipeline gets used to transmit the 3D assets down across the network to the runtime app. And most authoring formats are quite large. They're created for authoring tasks, not to be transmission efficient. And just as bad, they can take quite a lot of processing on the client application to actually unpack into the runtime application, which can be particularly painful in terms of performance and battery consumption on a mobile device. Then last but not least, the runtime app has to understand that custom format and tends to be then kind of one-to-one linked to the content coming down for this particular pipeline. So it's frustrating for all involved. So 3D really needs a transmission format. You know, we've been discussing this at the AR community meetings for several years now, so it's good to be making progress. And it's interesting to note that it's 3D, out of all the different data types, audio, video, images, it's really the last significant data type that's left that doesn't have a standardized format that many people can understand that also includes compression and streaming. And we're hoping that GLTF can fill this gap in the ecosystem. And it is interesting to have the historical perspective that when a compressed, widely adopted format appears in the industry and gets adopted by the industry, new opportunities, commercial opportunities arise for those media types, and applications and services arise around those media types. And we're hopeful that GLTF can be an enabler for the 3D industry in a similar way. So how would we use standards to help the 3D model creation and deployment pipeline? Well, people obviously still want to use the same set of tools, but we have, for a number of years, been developing the Collada authoring interchange format. It lets you flexibly mix and match the assets as they flow in and out of various tools. It retains full data information and integrity. And over the last year or two, the Khronos Group has been putting quite a lot of effort into making Collada a high reliability format with proven importer-exporters from the most popular tools and a full set of conformance tests that are freely available for people who want to create their own importers and exporters. But it's important to understand, just like the other proprietary tools formats, Collada is not a transmission format. It's way too big. It's not designed for efficient transmission. It's designed to be an authoring, interchange, and archive format. Nothing gets thrown away. Everything is human readable. Everything is built for flexibility rather than efficient transmission. So what would typically happen now is you'd have a transmission format, GLTF, and a format conditioner that would take your authoring format and format it into a GLTF file that is suitable for transmission across a network. And GLTF is built to be compact and easy to parse, again, particularly important on mobile devices. And we have actually now a open source Collada to GLTF translator that's already in open source on GitHub. So if you are using Collada in your pipeline, it's easy to jump from GLTF, Collada into GLTF. So the runtime app, which can be built around any of the GL APIs, but if you're running your AR in a browser, it will be typically WebGL. That runtime app can receive the GLTF format file and easily unpack it and use the assets in whatever it needs to do at the client. Many people doing WebGL applications, in fact, don't use WebGL directly. They use 3.js, and there are a number of other engines coming too. But 3.js is the most popular. And again, there's another open source component that we've uploaded onto GitHub, which is a 3.js GLTF importer. So if you are using 3.js for your WebGL app, you can use that to immediately import your GLTF assets. Now, we're not linking GLTF and Collada. People, of course, can have a format conditioner from any format that they wish. There's already FBX to GLTF conditioners in progress from Autodesk, for example. So you can convert to GLTF from any format that you wish. So the bottom line is people that use GLTF are happy, smiling people. So how does GLTF achieve all of this? What's the internals of a GLTF file? What is in the specification? So hopefully, again, to look back at the other data types, before we have GLTF, it's like in the imaging space, every camera were to produce a different file format, and every website and web browser would expect a different set of proprietary formats. Now, it would basically be a horrible experience to try and create a widespread image-based application. And 3D is in that state right now. So we're hoping that GLTF can be the JPEG for 3D applications. GLTF stands for GL Transmission Format. It's a runtime format. It's optimized to WebGL, OpenGL, ES, and OpenGL, the OpenGL family of APIs, but it's not particularly tied to the, OpenGL. It's just optimized for them. It's a compact representation for download efficiency. All of the mesh data is in binary form. We use the GL native data types as the transmission format. So I call it shovel ready. You can take the file as it appears over the network and immediately load it into a WebGL application with no complex parsing. GLTF does have all of the capabilities that you need to define full featured scenes with the hierarchy, materials, animations, skins, cameras, lights, and it's runtime neutral. We're not trying to dictate at all how the client application uses these assets. We're not trying to impose a particular runtime on any client applications. This is a bucket of assets that has the flexibility that you need to do anything you want with them in your own application. And GLTF, like almost every other Khronos standard, is extensible. So you can, if you have specific business needs, you can extend GLTF yourself. And one of the most fruitful areas we think for innovation and extensions are compression and streaming. So one level down, internally inside GLTF, we use JSON to describe the node hierarchy. That is typically quite small. It includes lights and cameras, and it references into the other assets contained within the GLTF file. And that includes vertices using the type-to-weight format that WebGL understands directly. It includes keyframe animations and skinning. We have shaders, GLSL shaders for any types of material shading. Textures to use existing compression formats like PNG or JPEG. And you can pack metadata in there too if you have need for metadata to be carried along with your assets. So this is a very simple example of a GLTF file. This is a one node with 3 subnodes. So the JSON is there that defines the vehicle, and there are 3 subnodes, which are the wheels, pair of wheels. Over on the left, this is a tool for visualizing a GLTF file, so you can visualize the node hierarchy. And there's some animations in this file too. It makes each of the pairs of wheels rotate. So this is a very simple GLTF example. So, well, where is GLTF in terms of its development? We're extremely close to launching GLTF 1.0. In fact, the target is to launch it next Monday at the HTML5 Dev Conference in San Francisco. But GLTF is an open specification with an open process. You don't have to be a Khronos member to see GLTF being developed, and obviously we're going to continue to develop it beyond 1.0. The spec is up on GitHub, and anyone is welcome to review and provide feedback and input. And as I say, the extension mechanisms are fully defined, and we're using the same extension framework as we have for other APIs such as OpenGL, where we have the concept of a vendor extension. So without any permission from Khronos or any of the Khronos members, any company can come and help define an extension to GLTF, and those vendor extensions that get widely used and adopted and are proven to be useful will very often get adopted into an official Khronos extension, and then potentially, if appropriate, into a core specification itself. So even though we haven't quite launched GLTF 1.0, we already have quite a lot of adoption around the industry. As I mentioned, 3.js has a loader. It's going to be part of the standard 3.js distribution. The other up-and-coming WebGL engine is Babylon.js from Microsoft, and the Babylon team are very close to having a GLTF importer for their engine. Caesium, which is a geographic information system engine that also uses WebGL, is using GLTF as its native format. There are a couple of applications already using GLTF also as a native format. GLTF is used in LibreOffice, and marketing companies like Amobi are beginning to natively import GLTF content. And I mentioned a couple of the pipeline tools already, Cloud to GLTF converter, but there was also some online conversion websites beginning to appear where you can online drag and drop different file formats and output a GLTF file. There's one that's being hosted by Caesium to convert Collada to GLTF if you don't want to build your own converter, and Autodesk are building an FBX to GLTF converter that should be coming online pretty soon after GLTF 1.0 is finalized. I mentioned extensions. The extensions is critical to any living specification, because once the specification stops evolving and moving, it dies. So it's good to see that there's already quite a lot of activity around GLTF extensions. Khronos is defining one official extension, which is the binary GLTF extension. Lets people define their own binary payloads. Fraunhofer, that have a lot of expertise in very large model streaming, have a quantized attribute extension that is very effective at enabling real-time streaming of very large models that kind of appear in more detail before your eyes, very applicable to many types of CAD application. And we're very happy to have Marius joining us, because he's really the driver of one of the first and most significant compression technologies that will be implemented as a GLTF extension. The scalable complexity 3D mesh compression technology has been around from MPEG for some time. The Open 3D GC open source implementation is being used in a GLTF extension that can be used to compress any 3D assets. And we have some preliminary results from taking various models, the classic Stanford bunny dragon, and the Collada duck, and some GIS data through the Open 3D GC GLTF extension plus gzip, and we're getting anywhere from 40 to 80% compression ratios. Now, I think this is a good start. We haven't finalized this extension yet, but this shows already the kinds of compression that we can get by using technologies like this on the asset payloads. Caesium has been one of the main drivers for GLTF, and they're beginning to deploy it in their geographic information system applications. For example, they have an open specification called 3D Tiles, which is a way to stream very large city models. So they have two levels of compression going on here. You only download the tiles that are visible, but within the tile, they're using GLTF, using the 3D GC extension, to compress the data that's inside each individual tile as it gets downloaded. So we're launching on Monday. We're already gathering quite a lot of industry support. I'm not going to read these, but you can see Microsoft with the Babylon engine, Autodesk. Box is interesting. Box see the opportunity to be a repository for 3D models that can be widely used in a variety of different applications. So they are very supportive of finally having a standardized 3D model format. And of course, again, Marius, who's on the call from MPEG, I think is going to be playing a key role in helping us compress and stream our payloads. So that's the end of the PowerPoint. Let's perhaps finish up with this call for action. Again, the specification is openly available, and we'd welcome any feedback. There's going to be a lot of information. Well, there's information there today. There's going to be more on Monday on the GLTF link there. And if you have any questions, or if any of the companies here on the call would like to provide a supportive quote for the press release, similar to the quotes we just saw, we would be delighted to include them. You can email them to me. My email address is there on the final slide. So again, thank you for your time, and be happy to get any questions or feedback.
Great, Neil. That's really a great presentation with the background, the history, the context in terms of augmented reality developers. I think that's extremely helpful. I'd like to now ask or invite Marius to share with us how he sees this, his point of view, what his experience has been in working in this process, and how he sees it going forward. Marius?
Thank you, Christine. Hello everybody. Yeah, so I'm Marius Preda, working in Institut Mines Telecom in France, but mainly working for a few years now in MPEG, Standardization Committee, and as you probably all know, MPEG is about compression mainly. So MPEG is doing video compression, audio compression, image compression together with our friends from JPEG. And the question is, are these the only forms that we can have for media to compress, or there are others? And we tried to answer to this question in '98 when we realized that we may need compression for meshes, 3D meshes and animation. And probably some of you remember, but in '98, there was a format, and there's still a format for 3D graphics, even available today, which is VRML 97. So VRML 97, for the ones who don't know what it is a textual format, a markup language for representing 3D graphics. And since then, I think there are plenty of other 3D formats that are available. So one of the problems that exist in the industry in general, it may be the lack of standards. But the other problem is when we have too many standards. And this looks to be the case for 3D graphics field. One of the questions would be, is GLTF yet another standard that will make some even more noise in the signal, or it can be the solution? And I have the feeling that it is part of the solution, because there are some features that GLTF has intrinsically, like being JSON-based, being already available and compliant with browser technology, having JavaScript near GLTF directly, natively, makes him a good candidate. Especially that we may say relatively with no risk that the web is the new computing platform and it will stay for some time. So I personally believe that GLTF can create the base for 3D graphics industry that will allow people and companies to add new features. And we need, in the 3D graphics world, we need to
Marius, I don't hear you anymore.
I hear you though, so I think it's Marius just dropped out.
Okay, thank you for letting me know that. That was a concern that I had. So, darn, I just he was in the middle of some really good information there. So maybe he'll be able to return and join us again. So he's probably still talking, as a matter of fact. But well, I'll try to reach him and try to get that get him back in. I wonder if maybe we could use this opportunity to see if there are any other questions. Is anybody interested in speaking or want to make a comment?
I think even before Marius dropped, I think we got the main message. So
yeah, here I'm again. So I don't know what happened, but yeah, I was kicked out. Okay, I don't know where it stopped. So my point was that we had a base that was needed in the industry that was not properly addressed before, even if we had plenty of formats proposed in the market, and we have to use this base and create what Neil mentioned previously, create the ecosystem that will allow to go to a real transmission format for 3D graphics.
Yeah, thank you, Marius. We appreciate that support, and you've been instrumental in helping us define GLTF. And I think, to your point, we've been very careful not to over-engineer GLTF. GLTF is not rocket science. It's actually quite simple in concept, and it's kind of the format work that everyone was kind of doing anyway in their own proprietary pipelines. So GLTF is actually quite simple, but it is an extensible framework. So we have, I think, a lot of opportunity to work together in the future.
Maybe, Neil, you could mention that we did make a presentation along these lines also with the Open Geospatial Consortium, and there was a suggestion there about where to go, how to proceed in the future collaboratively with another organization.
Right. Yes, because I mean, one of the I think the reason why 3D is the last of the data types to get its compression format is that the number of different use cases and modalities that you can use 3D in is more than an image or a video or an audio file. So that complexity, I think, has kind of held things back. And I think the way to solve that is with this extensible framework. Different vertical types of application will probably want to use their own types of compression, payload compression, and a geospatial application that has a very specific kind of use case modality where you can imagine quite easy ways of significant compression, like the 3D tiles example I gave earlier. So working with organizations like OGC, who have a lot of experience in the use of geospatial data, that they will be the perfect partner to see whether how much of the GLTF work we have they can leverage. Can they leverage things like the MPEG compression, or do they need something different? We definitely welcome working with other organizations that have that vertical domain expertise. And again, we hope that GLTF is this kind of neutral carrier that can enable the different industries to leverage GLTF, but also have the flexibility for their own particular use cases.
Yes. So Alex Hill, who's joined us, had a really good point. He raises the point, regardless of the industry and the use case, one of the ways that 3D content is different is that people manipulate it either directly or by changing their orientation, perhaps in an augmented reality, or their relative position to the real world. So this sort of much more, how do I say it, dynamic, and it's a manipulation, really. It's this. Have there been any thoughts about how to accommodate the user interaction? It's different than in images where people just take it in, or video, which is more of a, it's more passive.
Yes, that's right. I mean, an image, you can open it and zoom it, basically, but Alex is exactly right. The use case possibilities with a 3D model are vast, and there's all kinds of things you can do with a 3D model. But that's why it's important that we begin to enable the most obvious use cases with the core GLTF. So that's why we make sure that we have the scene hierarchy, and we have lights and cameras defined in the scene definition. So if you want to do the most obvious things with a 3D model, such as reorient it, resize it, everything is built into the GLTF scene description, so the client application can understand what's in the file and do all those normal kind of application type things using the assets very easily. You haven't lost that critical information from the authoring pipeline. Now, of course, though, if you want to do something that no one else has ever imagined before, do some explode every polygon so you can see the internal structure of the model or something, then of course, once the application loads up the assets, it is just assets, and the application can do anything it wants with them, including reparsing them into different meshes. So there's no limitation on what you can use the assets for. GLTF is just a carrier that can efficiently get the assets into an application for the application to do whatever it wants with them. You can go way beyond all the normal light camera interactions if you wish.
Okay, great. I think that's helpful. Maybe Alex can tell us if he has further questions. I'd like to ask Sam Murley, who's on the call with us today from Design Mill. He had a question about using how to migrate the existing technologies from existing technologies to this new framework. So I'm going to unmute Sam and ask that he go ahead and ask his question. Sam, it's all yours.
Okay, thanks, Christine. So we deal a lot of times with heavy CAD. We've got to take heavy CAD files and crunch those down into lightweight usable models for both VR and augmented reality applications. So my question was, is that process still way up front in regards to this standard and what you're proposing here in this workflow, or is there some direct tie into pulling high poly and heavy CAD models into this process itself?
Yeah, that's a great question. And so I've just brought up the slide, hopefully it's most relevant. So let me get that built back up. So like we were saying before, GLTF is not connected to Collada at all, and we have no need to link Collada and GLTF other than show an example of a standard-based pipeline, which hopefully is an interesting example for some folks. But if you have, and the example I've used here is primarily like DCC rather than CAD tools. So if you have a CAD model here, I would say that there's two comments I would make. you can certainly take a CAD model just as easily as a DCC model through your own conditioner into GLTF. So the reason, of course, we have the GLTF spec, and we try to keep it as simple as possible. For example, the Babylon guys had their importer up and running in three weeks from opening the document specification. It should be relatively easy to take your any CAD format you want, perhaps even your existing lightweight format, and condition it into GLTF. Now, so that will be kind of step one. The interesting step two is perhaps in the CAD domain, you're going to want additional data. Some of the CAD data you might want to pass along with the GLTF assets. In that case, we will be very interested to talk to you and work with you on perhaps a CAD extension where some of the tolerances and mechanical material data relevant to a CAD domain application can be carried along with the payload in a standardized extension that everyone can agree on.
Okay. Oh, that's great. So push it through the format conditioner, and then back into the workflow. Do you have time for one more question? It sparked another thought.
Sure.
That I had. Okay, so we're working with a few OEMs that develop 3D sensors or depth sensors, and my question would be, is that the same process then if we wanted to instantly capture objects or large scale objects, small scale objects? We could just push those potentially through the same process, through some type of format conditioner, and get that depth image or point cloud converted into the standard. Would that potentially work? Okay.
Yes, and well, actually, and that's another good use case that we've had some discussion on. And if you've already done the mesh reconstruction of your point cloud model, then yes, it's just meshes. It's going to be a big mesh probably, which is why it's important to get some compression going that we already talked about. Or we have had some folks that actually want to pass the point cloud itself as a payload. Now, that's not something that's in the GLTF 1.0 spec, but again, using the extensibility, we would be really interested to talk to you guys about a point cloud payload extension, because that has come up a few times. So we could go either way. And as your perhaps one last comment, as you're thinking about converting in and out of GLTF, one of the main reasons why we've done this complete pipeline from Collada into GLTF is that the condition that we've taking Collada into GLTF, that translator is in open source on GitHub, so you can use that as a starting point if you want to do variants on conditioners.
Okay. Spectacular. Thanks for the great answers.
Thank you, Sam. Great questions. Well, I don't see any other questions at the moment. Of course, we have the information, your contact information, Neil, for follow-up. Once again, the GLTF 1.0 press release is scheduled to go out Monday, so there's a deadline here if people have comments or would like to express their support. That's an invitation from Neil. And I want to thank everybody for their participation. Thank you, Marius, for your comments, and Neil for your fantastic content. And good luck with this. We're very happy to be able to support this information.
Thanks again for the opportunity, Christine.
Okay, great. Well, thank you very much. Bye-bye, everyone.
All right.